Hi, I'm Adrian, and in the next couple of minutes, I will talk about one of the projects that I worked on, and at the end, I will have a short demo. With this being said, I will start by mentioning that this project outlines an interface that aims to make the human-computer interaction more human-like, using only video and audio input. The interface provides control over a variety of functions, from basic tasks like moving the cursor or changing the sound volume, to more complex tasks such as playing video games or browsing the internet. However, in order to keep this video short, in this presentation I will talk about only one of the functions provided, and that is controlling video games. The gaming industry has evolved up to the point of photorealistic video games, but let me take as an example the racing video games. Playing racing video games using keystrokes is not even close to the real experience of driving, while gaming steering wheels might represent expensive hardware. The interface that I developed is based on an imaginary steering wheel. If the user raises two fists in the front of the camera, the interface knows to interpret these fists as a steering wheel. Having two fists allows us to compute the slope and, as a result, allows us to simulate a real steering wheel. The real-world steering wheel controls the direction of the car in concordance with two factors: the angle of the wheel and the amount of time the wheel is fixed in that position. As the racing video games take as input keystrokes, the direction of the virtual car is controlled by two similar factors: a key that represents the direction and the amount of time the key is fixed in that position. In other words, if we would use the same system that is used in video games on a real-world steering wheel, we would end up having a car that would not care about how much we steer the wheel, and care only if the wheel is turned to left or right. Therefore, the main challenge was to convert a system that considers only if a slope is positive or negative to a system that considers how positive or how negative the slope is. My solution to this problem was to compute the value of the slope, normalize the value, and at each frame start a thread that sends a signal for a period of time that is directly proportional to the value of the slope. At this point, a steering system is implemented. Next, support for acceleration and braking is required. To get closer to the real experience of driving, the interface should be able to distinguish between three scenarios: just steering, steering while accelerating, and steering while braking. For acceleration and steering, I used a different sign. When the interface detects two fists with the thumbs up, accelerates the virtual car but continues to keep track of the slope. This is the same algorithm used for only steering, but this time a signal for acceleration is sent continuously. For braking and steering, I used the same class used for steering, but added a part that computes the area of the detected objects. This way, if the user is moving his hands away from the camera for a considerable distance, the interface interprets the gesture as pressing the brake but continues to keep track of the slope. Now, let me show how this works in practice. This is the graphical user interface, and it was developed using Electron.js. And here we have a window that will provide us additional feedback. I'm now raising two fists in the front of the camera. Nothing happens. Now I'm raising thumbs up. Stop accelerating. Accelerate again. Steering slowly to the left. Stop accelerating. Accelerate again. Stop accelerating. Turning to right. Actually, let's press the brake. Let's accelerate little bit more. And then stop again. Now, let me show you how I control the sound volume. Now let me show you how I can manipulate the sound volume. I'll open this control so that what happens it's a bit more easier to understand. And now I'm decreasing the sound volume. And now I'm increasing the sound volume. And now I'm decreasing the sound volume again. And increasing the sound volume once more. Let's search something on the internet right now. Here I have a Wikipedia page open. Let's search something on Google. Search on Google machine learning. We are now on Google and our instruction is typed. We have our results and let's go back to where we started. Go back. And we can see now that we are back on the page where we started. Let's go forward now. Go forward. And now we can see that we are back to the results. Let's now stop the application. This concludes my presentation, but I have more interesting things to talk about, so if you want to know more, don't hesitate to get in touch. Thank you for your time.